Hello everyone, myself Manesh Kundu. I am currently pursuing my integrated PhD and IIS Bangalore, and these are the exams that I have already cracked. Okay, so I believe that everyone is unique. Okay, so I'm not going to tell you that yeah I am the best, but yeah it's me of course. So I love to explain everything in simple way. Okay, so my motto is simple teaching of selected topics. Okay, suppose you are reading a lot of things. Okay, I'm reading a lot of things. Okay, but everything is mugging off in your brain. Okay, uh, but it's of no use. So you have to be selective now. So I love to teach you some selected topics with real life explanations that will help you to understand the whole concept. Okay, few people believe that yeah, through fact I can crack the exam. Yes, I am also agree. But the thing is that the exams are not only the fit. Okay, that means if you crack this exam, this is not indicating that yeah you get a good institute. After this exam, you have to appear interview. Okay, so in interview they will ask you some experimental question. So you have to learn some experimental tricky question, how to solve them and understand the concept in appropriate manner. Okay, and another reason, okay, is that when we just were preparing for jam, gate, or TI for any kind of exam, okay, sometimes we are over motivated. Yeah, I can do anything. I can. It is easy for me. But after few days, we feel so low. Our energy just reaches zero. Okay. So sometimes we feel so motivated and sometimes demotivated. So my funda is that to keep you in a right track with work motivation balance, to understand yourself in a better way, to understand ourselves is the main thing because suppose I am taking preparation for jam but I am not really eligible, okay, for this, so that's of no use. At first we have to understand to realize ourselves. So my motto is to realize you, yeah, that it's you through some experimental teaching. Okay, so this is a study plan. I love to integrate cellular biology, molecular biology, and their application in plant physiology. So they are not different topics. They are just integrative part. Okay. In case of cell biology, I am covering basically plasma membrane. We know that plasma membrane is the boundary of the cell wall. Okay, sorry, of a cell. Okay, so how various kind of transportation occur. That means in here I just mentioned the car. Okay, there are a lot of collect pump, channel, uh, everything is there. So how molecules are transported inside the cell and from extracellular portion of the cell to inside of the cell. There are different kind of organelle. Okay, like mitochondria, lysosome, peroxisome, chloroplast, Golgi bodies, ER, nucleus, everything. And how cell shape is maintained. We know that cell is some kind of this shape. So in case of human, there are a lot of bones. Okay, cell has also cytoskeleton. Yeah, yes. And how the junction, suppose it is a cell. So they are in a tissue, how the junctions are maintained. Okay, then it is really beautiful and fascinating when you are just visualizing it. Okay, it will help you to achieve your goal in a broad sense. Exam as well as concept, because exam is beautiful when you have the concept. Okay, so after that, when cell feels tired, what to do? That means the apoptosis process. And lastly, the cancer, the unanswered villain. Okay, so lot of research has already done on cancer, but still it's not very clear because cancer is uh, a combination of lot of things: genetics, cell biology, molecular biology, lot of things. Then molecular biology. I would like to start from the basic how the concept of DNA, RNA, nucleic acid has come, then followed by how they are compacted. Like DNA is a broad things. How in a small cell they're compacted, okay, in their topological properties, okay, and how one DNA is just forming two DNA. What is the mechanism behind this? And if some kind of damage is happen, so what happen is damage is there, and how to recover this damage? That means DNA repair mechanism. Okay, there are a lot of DNA repair mechanism. It's really, really beautiful. And last is recombination. Few of us, in simple language, we say, I am like my mother, I am like my father. But okay, this child is not like father and mother, everything. But these are not so simple. A lot of recombination mechanism is there. Okay, but it's really so simple. And RNA processing, before RNA processing, it's transcription from DNA to RNA. Okay, because DNA has all the information, but protein is the ultimate worker. It can do so for from DNA to RNA, from RNA to protein. Okay, so transcription, then post-transcriptional modification like capping, poly A tail, and some kind of splicing mechanism, and then translation. How beautifully ribosome incorporate the mRNA and then build the protein. How the protein comes to the tunnel. Okay, to visualize these things. Okay, and then gene expression. That means when we're child, some gene express, some gene not, and when we are adult, they different kind of gene are expressed. Okay, so it's really beautiful that in which stage which gene has to express and which has to not. Okay, it's really fascinating. And then in case of bacteria, there is operon system like lac operon, TRP operon. Okay, and then post translational modification (PTM). We suppose they are the same gene sequence and RNA is same, but after some kind of translation, they perform different function through different modification like glycosylation. If you glycosylate a particular protein, it is inactive. Suppose, and if you just deglycosylate, then it's active. Phosphorylation, dephosphorylation. Okay, these are really, really interesting things. And then I will apply cellular biology and molecular biology concept in plant physiology to understand how the plant system works. Okay, not the anatomy portion, but how the fundamental portion like diffusion, osmosis, okay, happen. How plant absorb water from soil through root, and how plants make food. Okay, because making food is not a simple task. Okay, it's photosynthesis, lot of photon coming from sunlight, then light reaction followed by dark reaction, everything, and then nitrogen metabolism. It's really interesting part and lot of question asked from this part. Okay, and different kind of deficiency syndrome that happen like to zinc deficiency syndrome, like Chiari disease and boron, molybdenum, lot of things are there. And that is phytohormone like auxin, how auxin, gibberellin, abscisic acid, cytokine, ethylene works. Okay, how fruit ripe. Okay, it's really interesting, na? And uh, stress physiology. Suppose when there's exam, we are stressed. No, no, no. I have to study. I have to study. But how plant manages their stress? Suppose there's a heat stress. There is some kind of heavy metal stress, water stress. How plant will manage these things? Okay, and then plant development biology, like how anther and pollen and egg, everything is developed, and how just a plant is emerged. Okay, it's really, really fascinating rather than animal, I think, I guess. So I'm going to cover all these things with some experimental data in a wonderful way with correlation with cellular biology and molecular biology and the application of biochemistry as well in the case of plant physiology. Okay, so thank you. That's all.